Welcome. In this lesson, you're just going to use the properties of logarithms to evaluate logarithms. So if you don't have these three rules down, or properties, I'd have them written down, that the log of any base b to the x plus log of the same base b to some other y value, if you're adding those two logs together, we can combine it to be a single logarithm of x times y. Likewise, if we're subtracting the two logarithms with the common base of b, we can just take the first argument and divide by the second argument, or x divided by y. If we have a logarithm of a base b and it has x raised to the y, that's the same as taking y times the logarithm base b of just plain old x. Likewise, remember the log base b of any of the same base b raised to an exponent is just going to be the exponent, because that's what it means. So this first expression here, log base 5 of 5 plus log base 5 of 5, I thought right off the bat, oh, that's just 1 plus 1, because they cancel, leaves that exponent of 1. That's an exponent of 1, and that's an exponent of 1, which is 1 plus 1 is 2. Or you could combine them using this property, and log base 5 of 5 plus log base 5 of 5 is log base 5 of 25. What do you raise 5 to get it equal 25? 2. So the answer is 2. Again, this is a fairly easy one. You could do it one of two ways. Realizing 5 raised to the third power is 125, so that first logarithm is just a 3. The second logarithm, log base 5 to 25, well, 5 raised to the 2 power is 25, so that's 2, and 3 minus 2 is 1. Or you could use the properties of logarithm, combine it. Since it's subtraction, it's 125 divided by 25. 125 divided by 5 is 5, and log base 5 of 5 is just 1. Either way, you get a 1 as a solution. In this problem, we actually had to use properties of logarithms, because I don't know what you raise 4 to get it to equal 8. But since they're both base 4 and it's addition, I can combine by multiplying the 8 times the 8. That's 64. And then I realize 64 is 4 to the third power. So log base 4 of 4 to the third is just 3. So this one you had to use properties of logarithms in order to do it. Again, another one where the properties of logarithms have to come into a play. We're going to combine the two logarithms to make it 4 times 25, which is 100. Now remember, if you don't see a base, that's a common log, which means it's a base 10. So we could write a little base 10 there, but log base 10, or common log of 10 squared, is 2. So again, you're using your properties of logarithms and also realizing that that's the common log. Again, this one's just going to be 1 plus 1 or 2. Again, this one we'll have to do a little combining using properties of logarithms, which when we combine 20 times 5 is 100, common log or log base 10 of 100 is 2. Okay, now we're using a natural logarithm, which, remember, a natural logarithm is base e, and we're using the number e inside the logarithm. So natural log base e of e to the 15 is just 15. Natural log base e of e to the 5 is just 5. 15 minus 5 is 10. Or we could use properties of logarithm and divide e to the 15 by e to the 5. Using our properties of exponents, 15 minus 5 is 10. And again, log base e of e to the 10 is just 10. So our solution is 10. So some of these, there's a couple ways you can always go about it. Again, we can do this one. Just log base r of r squared is 2. Log base r of r to the 1 power is 1. 2 plus 1 is 3. Or combine them. Log base r of r cubed equals 3. This one we can't do without combining. We actually have to combine by dividing 192 by 3 to get 64, which 64 then is 4 to the third. And since this is a base 4 logarithm, we just get 3. In this one, there's 3 logarithms. Just like order of operations work left to right, it's very important that you divide 120 by 60 and don't multiply 60 by 4 first, because then you'd actually be dividing by 4 as well. So make sure you work left to right. 120 divided by 60 is 2. Then you do the addition, which becomes multiplication times 4 to get 8. If you did 120 divided by 240, you get 1/2, and you would not get the right answer. So work left to right when you have multiple logarithms. In this one, we had to use the power property, where I basically bring that 3 in. And so I have 5 times 3, which is 15. Just to make sure you understood, I did it down here. When I bring this 3 in, it's e to the 5th raised to the 3rd. Well, then we multiply those two exponents. That gives us 15. Then I subtracted, or in other words, divided the arguments, e to the 15th divided by e squared, because that's what we do when we subtract. That gave me e to the 13 inside, so going from here to there, and then I get just 13, because it's a natural logarithm, base e of e to the 13. With this one, again, if I use properties of logarithms, I get w divided by w to the 7th, because it's subtraction, which is w to the -6. And since it's a log base w, it's just -6. Or it might have been easier just to realize that log base w of w is 1, log base w of w to the 7th is 7, and 1 minus 7 is -6 again. Either way, you get a -6. If you make it to the 90s, you're going to have to realize or remember that fractional exponents, because this 1/4 will become an exponent, is a root. 4th root of 81 is 3. And then these are common logs, base 10. Log base 10 of 3 minus log base 10 of 30 is log of 3 over 30, or 1/10. But you write that in exponential form. 10 to the -1 is the same as 1 over 10. So you remember the negative exponents, which log base 10 of 10 to the -1 is -1. So make sure you remember your rational exponents and your negative exponents. I think you can get through the remainder of this on your own. If you do have any questions, please do not hesitate to ask.